understand from you have understood from last previous classes. So this what you have understood. Anybody can?
Snowflake architecture.
Mm. Yeah, Snowflake.
Architecture and virtual warehouses and cloud service layer
Mm.
and data storage.
Okay. What is a shared disk or nothing shared disk? What is a shared nothing?
Shared means it will distribute the storage across all the nodes.
Mm. Shared.
Shared nothing, then each node it will work independently. So
Mm. Independent. Okay. So okay. I will explain. Okay. So they ask a different way of answer. Okay. We'll type three points answer. So is my voice is clear, right? So to everybody, if you want to, you can record in your mobile audio. You can record, okay. So how are you going to answer for Snowflake architecture? Snowflake. So they going to ask like Snowflake architecture and Snowflake project architecture both are different. Okay, not same. Snowflake architecture and Snowflake project architecture both are different, not same. Remember this point. So now we are discussing Snowflake architecture. So that project architecture like layers, environments to include those everything end-to-end flow. So how are you going to answer? Okay. Yeah. So before understanding Snowflake architecture, so it is important to understand how database architectures like evolved. Like traditionally, databases followed either a shared disk architecture or a shared nothing architecture. So in a shared disk architecture, like such as Oracle, okay, those are like multiple servers share the same storage. Multiple servers share the same storage, so making data consistency easier, but the shared storage can become a bottleneck and a single point of failure. So what is a bottleneck? We when we go with the query profile, I will explain. Okay. So a bottleneck on a single point of failure. So in a shared nothing architecture, such as like Teradata, Greenbaum, and Apache Cassandra. So every server has its own CPU, memory, and disk, which provides excellent scalability but requires data partitioning across nodes. Okay. So Snowflake combines the advantage of both by using a multi-cluster shared data architecture. So storage is centralized and shared across all virtual warehouses. So while compute is completely independent and multiple warehouses can access the same data simultaneously without data duplication. So delivering high concurrency, better performance, independent scalability on cost optimization. Snowflake follows a three-layer architecture. Okay, storage layer, compute layer, and cloud services layer. A simple example is like a restaurant. The storage room represents the storage layer, where all ingredients are stored in the permanently. Okay, and similarly, Snowflake stores all tables, files, and data in cloud storage and automatically manages compression, so encryption and storage. So users never manage disks or storage devices, and data is stored on AWS, Microsoft Azure, or third one is, what is the third one?
GCP.
Yeah, Google
GCP.
Cloud Platform. So the kitchen represents the computer layer, where where chefs prepare food using ingredients from the storage room. So in Snowflake, virtual warehouses execute SQL queries by reading, filtering, joining, sorting, aggregating, loading, and transforming the data. So different warehouses can be dedicated to data loading, DBT transformation, Snowpipe, reporting, CI/CD pipeline. CI/CD means continuous integration and continuous deployment, or data unloading, and they will work independently. So finally, the restaurant manager represents the cloud services layer, so which is the brain of Snowflake. So it manages user authentication, security, metadata, query optimization, transactions, access control, and query history. So ensuring like every query is efficient to the appropriate virtual, that belongs to the virtual warehouse. So which is to which one? Okay. So this architecture makes Snowflake highly scalable, performance, highly performance, and ideal for modern cloud data engineering. So green tea. Okay. So ideal for cloud data engineering. Okay. So when you are explaining about Snowflake architecture, do not start with the database store layer, query processing layer, compute layer, cloud service. First, go with these. Okay, uh, shared disk architecture. Use that word, shared nothing architecture, and then explain about two lines. Then go with what is Snowflake. Combines the both multi-cluster shared data architecture, then multi-cluster warehouses we have in the Snowflake. Then about go with three layers. Then give any example like restaurant, and match with the layers. Okay, this is going to be okay. That guy having real time so experience this thing. Okay, like that. So now, so what we going to discuss now? Okay, so we already seen about I think few people know about these micro partitions, right? So now we're going to discuss the main is why theory is there, but why I'm taking so like now I'm not simply we can complete 5 to 10 minutes architecture micro partition cluster key, but that is not good way. So you need to get everything. You need to know about everything, because of suppose if you're going to write any certification exam, so those what I'm explaining here, they're going to ask only those things. You no need to go with no need to go with other things, other videos and other dumps. Okay, what I'm giving explaining in the class. From this class, you can clear any certification exam, architect, admin, develop, so core, pro, everything you can clear. So just this is what I'm explaining in the class. That's enough. Okay, I'm explaining everything. So yeah, of my knowledge. Okay, I think okay. So here in last classes, so we understand what is a data warehouse, why Snowflake was introduced, and how its three-layer architecture works. So now we are going to learn the internal features that make Snowflake one of the fastest and most efficiency cloud data warehouse. So these topics are very important for interviews because they explain how Snowflake achieves high performance without requiring users to manage indexes or partition manually. Okay. And here, what are the micro partitions? If you anybody know, just explain. Then I will explain. So it's must like interactive, guys. Okay. Simple like go, you don't understand anything. Again, you need to read again. So if you say something, then you can learn in the class, only in this session only, everything. Anybody?
Micro partitions are like immutable. Once created, it cannot be changed.
Yeah, yeah, good point. Shiva?
Yes, micro partitions are smaller in size, 50 to 500 MB.
Okay. Sam?
Mm. So micro partitions, I'm not very sure, but I guess the data is stored in micro partitions,
Okay.
and that's true in AWS or GCP or there, because it's in the cloud. These are the these are the only three places where the data will be stored, but it's stored in micro partitions, so that there's not, I mean, so you can better utilize the data.
Okay, fine. Good, good. So, Shabat, are you familiar with the data warehouse?
Uh,
Uh, yeah, a little bit.
Okay. Can you tell about something, two, three lines about indexing?
Indexing.
Yeah.
So
Yeah.
when structured data is stored, right, we can create an index to query it. It's like a pointer.
Yeah. Okay. Yeah. Okay.
right, like I said, according to me, just like I said, I just want to continue what I was saying. So it's like the data is stored in partitions, so that whenever you want to retrieve the data, it is slightly faster. So it is in like a continuous form or whatever, but it's in small bits.
Okay. Yeah. Good, Sam. So, okay. Thanks to everyone. Okay. Good, good, Sam, Sanjay, Shabat, Shiva. So here, so have you worked with indexes? Yeah. In Snowflake. Okay. And think we have unique indexes. Remember? Okay, some other we have three, I think three types, I think. So. Okay. So are we working with this indexes? Okay. So are we working with indexes in Snowflake? Okay. So here Snowflake not support for indexes. So instead of indexes, we have micro-partition and cluster. And this is one question. And how the data stores in Snowflake. Okay. In Snowflake. This one. And what are the micro partitions? A micro partition, the micro partition explain. Explain. Okay, what are the micro explain like this? Okay, how we work with index in Snowflake, how the data stores in Snowflake, and what are the micro partitions in a partition, and explain about cluster T. Cluster T. Okay, so and explaining about these type of this is the way of okay they're going to ask the questions of micro partition. So what is the micro partition? So I'm taking so think I'm taking one L records. I have table. So that having one lakh records. So many time. So 1 lakh records. So I want to select like start from uh, transaction. So start from transaction where ID okay equal to okay 76,000 I to 1. Sorry. Uh, 7 lakhs 7 lakhs total 1 lakh, right? Sorry, 76,000 I to 1. So now we need to fetch about these details who having the ID 76,821. We need to fetch those details from that table. So now after running this query, after submitting, so what is going to happen? It's going to scan the 1 lakh records. Okay. So 1 lakh, if only one partition and without partitions, what are you going to have? So it scans all data, take time and cost, more cost. Okay. Take time and more cost here. So if only one partition, so then without partitions, it scans this query. When you run this query, we have one line records, right? So if only one partition, so without partitions, it scans all data and it takes time and more cost. Okay, this is one way. Okay, without partition. Now after partition, it will take time and cost. Think like it's going to take okay, like 6 minutes. Okay, and $6. Okay. So after partition, if you run same query, this one. Okay. After partition, are we going to 1 to I'm going to 1 lakh records. So I'm taking 4 partition. 1 to 25K, one partition, and 25K to 50K, one partition, two second partition. Okay. Then third one is like 50K to 75K. So third partition. Then 75K to 1L, fourth part. Here now, see, select start from transaction where ID equal 76821. Now what is happening? Now Snowflake scans only these fourth partition and it will skip these partitions. Okay, Snowflake scans these fourth partition and it skips these three partitions. So then here it will take, okay, like so here taken 6 minutes, $6. Okay, and now we have have partitions, right? 6 minutes means like 90 seconds, 90 seconds, 90 seconds, 90 seconds. Now here it taking time. So less time, less cost, low cost, low cost. And time here 90 seconds. So it means like this is the example I'm giving. Okay, example. Okay, $1.5 the cost. So we are saving time and we are saving the credits also. Okay, that is $6. This is $1.5. So here $6, 1.5. Like what is the difference? So $4.5 we are saving, right? So when we have the partitions, okay, 4.5. Okay. So these are the micro partitions. Okay. These are the micro partitions. 4 partitions. When we have the partitions, so we are saving $4.5 and we are also saving time 4 minutes here, but we are saving the 270 seconds here. So saving 270 seconds. Okay. Right, 90 seconds and $4.5. So this is when we have the micro partition. Without micro partition, $6 $6. So with micro partitions, So 250 is 90 seconds and $1.5. So saving 270 seconds and $4.5 saving. Okay. So we are saving time and money. Okay. Wait, guys, no charge. Okay. So the same time and credits both we are saving. So this is when we have the partition. Okay. So what is Celestar root transfer with ID equals 76821. So it scans these partition. It will skip these partitions. That is query pruning. Query pruning. Okay. Uh, when we run the query in Snowflake, it scans relevant data, skip the irrelevant data. So that is query pruning in Snowflake. They will ask what is a query pruning. So when we run query in Snowflake, it scans relevant data and skip the irrelevant data. So that is query pruning Snowflake. So remember this part. Okay. So now you got it right. Why we need to have micro partitions. So and these micro partitions like one of the most powerful feature of Snowflake is micro-partitions. Whenever we load data into Snowflake table, Snowflake automatically divides that data into small optimized units called micro-partition. So as a developer, so we never create or manage them ourselves. So Snowflake handles everything automatically. So each micro-partition typically stores about 50 MB to 500 MB. Okay, I will show the diagram. Okay, okay, I will show the latter. So each micro partition stores, okay, stores about what 50 MB to 500 MB of uncompressed data. Uncompressed. We have compressed and uncompressed, right? So uncompressed data. Data. Okay, here. So this automatic organization allows Snowflake to scan only the required data. So instead of reading the entire table. Okay. So that is one of the key reasons Snowflake delivers excellent query performance. Okay. Think we have like we have one library. So with 1 million of record. Okay. Just one example. Library. We have library. Yeah. With 1 million of books. So here, if the all books were placed in a single room without any organization, so finding one book would take a long time. So instead of the library, instead of the library, organize books into the shelves by category. Suppose science, mathematics, social, Telugu, English, Tamil, Urdu, Kannada. So aeronautical, aerospace, department wise or category wise. Okay, instead of the library, organize books into the shelves by category. So when someone requests a programming book, okay, or aerospace book, okay, uh, the library and goes to direct to the programming section instead of searching the entire library. Snowflake works in exactly the same way. Instead of scanning the whole table, it scans only the relevant micro partitions. Okay, relevant. Okay, here see, Snowflake scans relevant data. It means like relevant micro partitions. Skip the irrelevant data. It means irrelevant micro partitions. Okay, so instead of scanning the whole table, it scans only the relevant micro partitions that we need to call if the relevant micro partition and skip the irrelevant micro partition. That's we can call query pruning. So how micro partitions improve performance? Okay. Suppose you have a sales table containing 5 years of sales data. Sales table, okay. 5 years of sales data. Okay. So you going to run one query, select. You going to run one query, select star from sales. Okay, where sales date equal to take like 2026. Okay, and 07. And take like 0, 1. Okay, we run code like this. Okay, so we are using the where class here. Okay, select star from uh, select star of sales where sales date 2026 equal to, sorry, sales date 2026 701. Okay, so here what is happening? So without micro partition, the database might scan every row in the table, and with Snowflake, so without micro-partition, the database might scan every row in the table. So with Snowflake, so metadata identifies which micro-partition contain the request date. So all those partitions scanned, the remaining partitions skipped. The significantly reduces execution time and compute cost. Okay, compute cost. This going to check only for this date. Okay, so only those parts are scanned. Okay, here we have like metadata. So with Snowflake, metadata identifies which micro partitions contains the requested date, and only those partitions are scanned. The remaining partitions are skipped. This significantly reduces execution time and compute cost. And the next, the main what is metadata. You know what is metadata? Anybody having idea about what is the metadata?
Yeah, it
Yes.
is
So
located in cloud service
yeah,
layer. So it holds the, metadata about the tables and micro partitions.
Come again.
It is located in the cloud service layer.
Okay.
It holds metadata about tables and micro partitions.
Yeah. Good. Good. Okay. So yes, correct. Okay. So here, what is metadata means? Like metadata is simply means data about data. Okay. See, simple data about data. That is metadata. So Snowflake automatically maintains the metadata for every micro partition. Okay. So this metadata includes like here, so minimum values. Okay, and maximum values. Okay? Minimum values and maximum value. Then number of rows, and then column. statistics and file information and distinct keys. Distinct, okay, and null values, okay, and includes minimum values, maximum values, number of rows, column statics, file information, distinct, null values, okay, these things, okay. So Snowflake uses this information to decide which partitions need to be scanned. So users do not manage metadata manually. Okay, users, we do not manage metadata manually. Snowflake manage everything. So using these information like main values and main, using this information to use this information to decide which partition need to be scanned. So we don't manage these things. It will manage with the by complete Snowflake and rejoin with the